So this is a briefing is intended to introduce Wind River to our aerospace and defense technologies. So we're going to cover a number of items in the agenda, have a look at challenges in the industry, look at what it means by the future is software defined, have a look at some enabling technologies we see in the commercial world, and then take a look at Wind River's solutions and customer successes. And then we'll finish off with a discussion on where you're going. So today's challenges really are based around the fact that most of the functionality in systems is based around software. Software is, in fact, if you like, the brains behind a lot of defense systems. And the high cost of software design, development, sustainment, retrofit and upgrade is really one of the key factors and costs in defense projects. And there's a couple of charts here that show, reports on how, in this case, airborne software has increased in complexity and is a major factor in the development process and costs associated with programs. And also that reliance on software is increasing as we think about more software-defined systems, as introducing things like artificial intelligence and machine learning technologies and autonomous systems that are really heavily dependent on software. And added to that, we have this challenge of cybersecurity that adds to that process. So the lengthy and costly certification processes we have to go through with software really drive the cost within systems dependent on software. So when we say the future is software defined, it really breaks down into a number of areas. The highest level really is that of digital transformation. And digital transformation really covers a number of different factors, not just software, but really moving the entire lifecycle process for programs into the digital world. And that includes a number of different things, ranging from how you develop software, how you manage software through the life cycle, how you deploy software, how you test systems based on things like digital twins, how you introduce new technology like AI and machine learning. So that digital transformation aspect covers a whole host of different capabilities that systems are moving towards. And in order to implement a lot of those things, we're seeing a huge move towards open architecture systems. In past systems, each functionality or functional unit would be developed as a standalone system. And as a standalone system, it would be maintained throughout its life cycle and upgraded when needed. But really that's not an affordable solution. So the move to open architectures really allows us to have more open systems based on standards. This gives us a much more affordable software architecture that allows us to deploy applications developed with things like DevSecOps on heterogeneous systems based on common COTS hardware platforms. And of course, on top of all of those nice things that we're looking at, we have to think about safety and security. What safety regulations do we have to follow for systems in the field? How do we introduce new technology like AI and machine learning into that area where it hasn't been pushed before and make sure that it's still safe? How do we then secure the systems to make sure that we're following a proper security assurance culture and building security into the entire system from start to finish? And of course, these are all life cycle issues. We have to manage that throughout the life cycle of the system. So we can't assume that an old system is going to be easily destroyed and the software content removed correctly. We have to think about how that's done in the correct manner. And so you're really building in security from the design phase all the way to the end of life phase of systems. So added to that, in the commercial world, we have a number of enabling technologies in different areas. So if we think about digital transformation, we're very much within the commercial world moving to software as a system or software as a service. And this really is a distributed way or distributed model of software deployment. Rather than having an application built specifically on a platform, it's actually stored in the cloud and run as a service, typically through a web browser or something like this. So that's really a different deployment method to what we used to within the aerospace industry, and it makes it much easier to deploy applications in a very rapid, innovative way. Added to that, we've got new technologies such as 5G and multi-core processors and GPGPU. 5G really starting to roll out in the commercial world, not just increasing the bandwidth of systems, but enabling new revenue streams and new ways of doing things where we previously maybe had the cell network restricted just to the capabilities of cell phones, but now we can make use of 5G for doing all sorts of other new applications as it has a low latency compute option, which means we can use it in some control and sensor applications. And multi-core processors really give us the performance and isolation we need to host a lot of these new technologies and new applications on target systems. And of course, GPGPU and AI processors are giving us the performance capability to bring AI and machine learning to our target systems. Open architectures really are driving this move within the defense industry. So if we think of architectures like MOSA or FACE, these really give us a framework for building systems that meet the requirements of next generation systems, providing standards-based APIs for applications, providing virtualization so that we can isolate from a security and a safety point of view, and learning from other industries where this has been achieved, such as automotive with technologies such as AutoSAR. And then finally, safety and security, the ability to have mixed criticality systems within aviation has already been tried and tested over the last 10 years. And then migrating that and adding the security risk framework approaches gives us, concepts on how we can, enable safety and security of these modern systems, and implement some really interesting features like predictive maintenance and other nice technologies. So that brings us to an introduction to Wind River. We were founded in 1981 as an embedded tools and operating system company, but really now we're the embedded industry leader with something like 40% market share within embedded software, billions of devices running our technology across different industries, and over 1,200 employees. Specifically in aerospace and defense, we have over 600 customers worldwide, and we've been involved in multiple programs, including over 550 safety certification projects. And these really operate across space, air, land, maritime, and cyber domains. More recently, we've acquired StarLab, and StarLab are instrumental in securing Linux-based systems within the aerospace and defense area. And we'll talk a little bit more about their technology. But again, this shows our commitment to the aerospace and defense world by expanding into secure anti-tamper type areas with StarLab. In terms of companies that use Wind River technology, we are used by all of the top aerospace and defense companies worldwide. These companies trust Wind River. You can see customer videos and testimonials on our website and on YouTube, and it covers the whole remit from commercial aerospace through the defense companies worldwide. Following open architectures and standards is critical in this industry, and this chart shows some of the certifications that we have achieved with our technology. On the top row here, we see type certificates and supplemental type certificates of aircraft that are flying with our operating systems, both as single use VxWorks and virtualized versions running ARINC 653 standard. And the top right is actually showing you the FACE conformance certificate that we've just achieved for our Helix virtualization platform. This is conformant to FACE Technical Standard 3.0. At the bottom, you see the recent achievement of being certified on our VxWorks operating system to the POSIX PSE 52 real-time controller standard. Again, supporting open standards, open architectures is key in achieving affordability in the long term. And also, we've won many awards across the industry with our product lines. And this is just showing a quick snapshot of some of the awards we've won recently. Things like the Military and Aerospace Platinum Award from the VxWorks 653 product, but also all sorts of other awards from different vendors showing the success of our products, such as our Linux Award for fierce innovation in telecom, and other awards at different shows. And our product portfolio is mapped to what I talked about earlier, covering operating environments, virtualized systems on the edge, and then lifecycle development tools. So starting at the bottom, you can see our VxWorks and VxWorks 653 operating systems. These have been safety certified and are deployed in, not only ground maritime systems, but airborne systems where a safety certification requirement is needed. And then our Wind River Linux product line supports open source development on Linux. It's based on the standard Yocto deployment. We provide full services to provide both security shield and custom developments of Linux for safe deployments. On the virtualized edge, we then have the Helix virtualization platform providing static or dynamic mixed criticality systems based on a VxWorks core. This allows us to virtualize environments and also have mixed criticality, including DO178C level A applications running there. And that's the platform I mentioned earlier is conformant with the FACE standard. On the cloud scale side, we have Wind River Cloud Platform that supports a variety of open standards and open architectures, including Docker, Ceph, and Kubernetes. On the lifecycle development tools, we have our Workbench environment and compilers that allow us to do program development on deployment on different platforms. A CIMIX simulation tool, which really provides the capability of having digital twins or automated testing within an agile or DevSecOps environment within the embedded space. A very powerful tool that allows us to test and run things like cybersecurity functionality and safety functionality before we deploy our systems. And EdgeSync comes from our automotive experience, allowing us to do software over the air, firmware over the air updates, and managing our deployed systems within the field. On the left-hand side, we see the new products from StarLab, which includes both the boot capability to make sure we have a secure boot, security hardened hypervisors, and then cybersecurity tools and components for runtime deployment of Linux systems. Give you an idea of some of our customers. This is Collins Aerospace. Collins Aerospace wanted to move away from their traditional single core platform into a multi-core system, and by doing that, evolve their business model so that they could easily insert new applications within their environment, whilst at the same time supporting their legacy IP that they'd already developed over years and deployed on systems, giving them a nice platform for growth. Now, of course, the challenges they faced around how you provide a platform that reduces that safety certification risk, migrating legacy applications forward and supporting standards was really what they were looking for. And so they looked to a solution from Wind River that allowed them to consolidate mixed criticality systems and still conform to industry standards such as ARINC 653, POSIX, and FACE. And this provided a nice platform for them to, to upgrade to the next generation systems. And again, there's some nice videos you can see on YouTube that show this. Another example is Northrop Grumman looking at cockpit digitization program. Here, again, they were trying to protect the long-term investment for multiple platforms in this environment, following the FACE technical standard, and at the same time achieve DO178C certification. So again, this is trying to consolidate avionics on a multi-core hardware platform, giving them maximum performance and lower lifecycle costs. And the real challenge was following the the government initiatives around the FACE technical standard in ways to manage these lifecycle costs. Again, they turned to Wind River to use our VxWorks 653 platform, removing that risk of conforming to the FACE standard and also having a proven path to certification. On the commercial side, a good example is Airbus Helicopters Helionics platform. This is running with VxWorks 653. The concept here was moving towards a standardized avionics platform that could run across multiple helicopter lines, such as the smaller helicopters shown here, or moving through medium and larger helicopters. So they wanted to consolidate multiple systems into a single IMA platform and have that consistent across their entire line. And the solution really was around a platform that supported IMA and ARINC 653 to provide that consolidation mechanism using a industry standard software platform, and then take that through the certification process for commercial use. Finally, an example of CIMICs. This is General Dynamics for the Fermi Gamma Ray Space Telescope. Again, building space equipment tends to be very, very expensive, and the amount of hardware available for testing is very, very limited. So trying to test all of the space flight software is very expensive and difficult to complete without flying the system. So CIMICs was used as a full system simulator that provides access to every engineer within the team, giving them a full software development and testing environment, such that they can run the binary code that's going to fly on the final system in a test environment, run it through all of their test processes and make sure that it's thoroughly tested before flying. This also allowed the operator to see how the software would be running on the final system and do operator training prior to launching the system, which gives great benefits and advantages to this project. So there's a whole host of other examples, success stories. You can see these on our website with videos and customer stories that show different applications, whether it's, for instance, the experimental Project Zero shown in the bottom right here, which is an all-electric unmanned vehicle looking at new technology for the next generation of aviation systems, or the NASA Robonaut shown in the middle, or the Boeing 787 in the center here, which is flying with VxWorks 653 as the common core platform, supporting multiple applications at different safety levels, or deep space missions like the Mars Pathfinder shown on the right here. There's a whole host of different systems that rely on Wind River and our technology for current and future systems. So really, that brings us to the final slide, and that opens up the discussion to see where you see your organization moving in the future, and how you might we might be able to work together to figure out how we can enhance our partnership.